We now discuss the solution of a problem from the section Coordinate Geometry. The problem is on the concepts of ellipse and circles, and the related concepts are also used. And this problem has appeared in JEE Main exam held on 25th July 2021 in the morning shift. The problem is, let an ellipse E whose equation is given by x square by a square plus y square by b square is equal to 1, where a square greater than b square passes through the point under the square root of 3 by 2, 1 and eccentricity 1 by root 3. If a circle centered at focus F, whose coordinates are alpha, 0, where alpha greater than 0, and radius 2 by root 3 intersects the ellipse E at 2 points P and Q, then PQ square is equal to, we are given 4 options. Let's now discuss the solution of the given problem. We have the ellipse E whose equation is given by x square by a square plus y square by b square is equal to 1, where a square greater than b square. So that means the major axis, the semi-major axis A is greater than the semi-minor axis B. And for such equation of the ellipse, we have the eccentricity is equal to under the square root of 1 minus b square by a square, and these are the two foci F1 whose coordinates are AE, 0 and F2 is minus AE, 0. Note that the focus F1 is on the positive x-axis because A greater than 0 and E greater than 0. Given E passes through the point whose coordinates are under the square root of 3 by 2, 1 and eccentricity is equal to 1 by root 3. Because E passes through this point, the coordinates of these points must satisfy this equation, and the eccentricity is given by this formula, and that is equal to 1 by root 3. So 1 by a square, wherever there is x, we write root 3 by 2 whole square plus y square, y is 1 by b square is equal to 1. That is the substitution of the coordinates of this point in this equation is this equation, and E, the formula is under the square root of 1 minus b square by a square, that is given to be 1 by root 3. So now simplify, this will be equal to 3 by 2a square plus 1 by b square is equal to 1, and squaring this will get 1 minus b square by a square is equal to 1 by 3. Now this equation is written as it is here, and b square by a square is sent to the right hand side and 1 by 3 is sent to the left hand side. You will get b square by a square is equal to 2/3. So that is b square by a square is equal to 2 by 3. And then this will be 3b square is equal to 2a square also you can write. So this first equation as it is, and this is 2a square is equal to 3b square. Now in the place of 2a square in the first equation, substitute 3b square. So this is the one, and on substitution what you get is 3 by 2a square is 3b square. and that is 3 cancels. 1 by b square plus 1 by b square is equal to 1. That is 2 by b square is equal to 1. That is b square is equal to 2. B square is equal to 2. And if b square is equal to 2, substituting in this, 2a square is equal to 3 into b square is 2, 6. And a square will be 3. So this will imply a square is equal to 3 and b square is equal to 2. Thus, we got the equation of the ellipse E. So the equation of the ellipse E is x square by 3 plus y square by 2 is equal to 1. And it can also be written by taking the LCM. The equation of the ellipse is 2x square plus 3y square is equal to 6. We continue in the next slide. We have the ellipse E, which we have seen in the last slide. 2x square plus 3y square is equal to 6. And the eccentricity E is equal to 1 by root 3. The center of the circle is the focus. We are drawing a circle whose center is at the focus f alpha comma 0 of E. And where alpha greater than 0, that means this is the focus that lies on the positive x-axis. On the positive x-axis, the focus is AE comma 0. So therefore, alpha is equal to AE, where A is root 3 and E is 1 by root 3. So alpha will be equal to 1. So we are drawing a circle with the center at f1 comma 0 and radius 2 by root 3. So the equation of the circle with center f at 1 comma 0 and radius 2 by root 3 is x minus 1 whole square plus y minus 0 whole square is equal to 2 by root 3 whole square. That is x minus 1 whole square plus y square is equal to 4 by 3. This implies, after taking the LCM, C is given by 3x square plus 3y square minus 6x is equal to 1. After simplification, we will get the equation of the circle C as this one. Now, this circle and that ellipse are intersecting at the points P and Q and required to find the PQ square. That is the problem. We will now find the point of intersection of the ellipse E and the circle C. So, ellipse E is this equation, circle C is the second equation. Now, in the place of 3y square here, you write 6 minus 2x square. So, 3x square plus 3y square. 3y square is written as 6 minus 2x square from the first equation minus 6x is equal to 1. Simplifying, we will get x square minus 6x plus 5. And factorization is very easy. And x minus 1 into x minus 5 is equal to 0. This implies x is equal to 1 or x is equal to 5. We reject x is equal to 5. Why? The reason is, for this ellipse, mod x is less than or equal to root 3. And mod x is less than or equal to root 3. Therefore, x is equal to 5 is not satisfying that one. Therefore, we reject it. We reject x is equal to 5 because mod x is less than or equal to root 3 for our ellipse E. So, we have only x is equal to 1. When x is equal to 1, what is the y? And those will be the 2 points for P and Q. Now, x is equal to 1 and 2x square plus 3y square is equal to 6. In that we substitute and we will get 3y square is equal to 4. And y square is equal to 4 by 3 and y will be equal to plus or minus 2 by root 3. So, there are 2 points of intersection, that is 1 comma 2 by root 3, let us call it as P, and 1 comma minus 2 by root 3, let us call it as Q. So, therefore, the points of intersection of the circle C and the ellipse E are given by P and Q. And notice that they lie on the same line, x is equal to 1. x is equal to 1. Therefore, the distance between P and Q is 2 by root 3 minus 2 by root 3, that is equal to 4 by root 3. And PQ square will be 4 by root 3 whole square, that is 16 by 3. You can also calculate PQ square other way around. This is a point x1, y1, x2, y2. The distance between these two, the square of it, that is what we is computed here, and that is equal to 16 by 3. Let's look at our options. And our answer 16 by 3 appears against the option 2. Therefore, our answer is option 2. That is the discussion of the problem from the section coordinate geometry, which is based on the concepts of ellipse and circle. I hope that you have understood the solution of this problem and go on working out problems related to circles and ellipses and hyperbolas from the coordinate geometry, and they are very, very important. I wish you all the best. Thank you.